calculating probabilities. If you want to predict the chance of something happening, you use probability. If you want to predict the chance of something happening, you use probability. So an experiment is a repeatable process that gives rise to a number of outcomes. So an experiment is a repeatable process that gives rise to a number of outcomes. So you can repeatedly throw the dice and you get different numbers. Or for the spinner, you can spin it, you can get a 2, you can get a 3, you can get a 4. Or for this other spinner, you can get blue, you can get red, you can get yellow. And so that's a repeatable process, and it's an experiment. And you get an outcome. An event is a collection of one or more outcomes. So an event could be when you spin this, when you throw this die, the event could be getting a 4, probability of getting a 4. Or if you spin this spinner, probability of it landing on 3. Or probability of it landing on an even number. For this spinner, probability of it landing on red. There's 1, 2, 3, 4, 5 red. So that gives you the event, a collection of one or more outcomes. A sample space set of all possible outcomes. So everything that is possible. So for this spinner, all the 8 numbers are equally likely. So that's the sample space. And for this one, all the different colors are equally likely. So here are the definitions for you to try and learn them. An event is a collection of one or more outcomes, a sample space set of all possible outcomes. And when outcomes are equally likely, the probability of an event is divided by the total possible outcomes. Example 1. 2 fair spinners each have 4 sectors numbered 1 to 4. The 2 spinners are spun together and the sum of the numbers indicated on each spinner is recorded. Find the probability of the spinners indicating a sum of exactly 5 and more than 5. So I've got spinner 1 there, highlight in yellow, and spinner 1 there. Spinner 2 in blue and spinner 2. So when you spin them, if spinner 1 lands on a 1 and spinner 2 lands on a 1, you add them 1 plus 1, it gives you 2. So you record 2. If it lands on spinner 1 lands on 2, spinner 2 lands on 1, you add them 1 plus 2 gives you 3. And if spinner 1 lands on 3, spinner 2 lands on 1, you add them together, 3 plus 1, it gives you 4. If spinner 1 lands on 4 and spinner 2 lands on 1, you add them together, 4 plus 1, it gives you 5. So that's what you do to complete the total possibility space or the sample space, everything you need. So there's 1, 2, 3, 4. 1, 2, 3, 4. So 4 on that side, 4 on that side. So 4 times 4 is 16. Or you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you draw a sample space diagram. So that's a sample space diagram showing all the possible outcomes. 1 and 4, it gives 5. 2 and 4, it gives 6, showing all the outcomes. And there are a total of 4 times 4, which is 16 points. And each of these 16 points each of these 16 points are equally likely. So for part A says a sum of exactly 5. How many numbers have sum of exactly 5? If I color them in yellow, there's 1, 2, 3, 4. So there are 4 outcomes for that. So the probability of 5, you write it like that, P probability bracket 5 is equals to 4/16. And you simplify it, you get 1/4. And the probability of more than 5. So to get more than 5, we can count how many of the numbers. So we can count 1, 2, 3, 4, 5, 6. So there are 6 sums which are more than 5 for this part. So the probability of more than 5, this is a shorthand way to write it, is equal to 6/16. And you simplify it, it gives you 3/8. Question number 2. The table shows the times taken in minutes for a group of students to complete a number puzzle. The time in minutes is at the top, and the frequency, the number of students, is at the bottom. So for 5 to 7 minutes, 6 students. 7 to 9 minutes, 13 students. 9 to 11 minutes, 12 students, and so on. A student is chosen at random. Find the probability that they finished the number puzzle in under 9 minutes. So we want to find the probability they finish in under 9 minutes. So we write it like probability in bracket finished under 9 minutes equals to, let's count how many in total finish under 9 minutes. So we got 6 plus 13. So 6 plus 13, it gives you 19. So these are the ones who finished under 9 minutes, because it says here less than 9. This says less than 9 minutes. So all these ones finished under 9 minutes. So 6 plus 13 gives you 19. And how did we get 40? At 6 plus 13 plus 12 plus 5 plus 4. You add all of them, it gives you the total of 40. And find the probability that they finish the number puzzle over 10.5 minutes. Over 10.5 minutes. So we are going to use interpolation, because if we want to look for 10.5, it's not exactly easy to find that point. So we're going to use interpolation. So 10.5, this is where 10.5 is. We're using interpolation, and it lies 3/4 of the way. So if you start at 9 and end at 11, 10.5 is 3/4 of the way. So if this is 1/4, and then another quarter, and then you get to 10.5. So 3 of them, 1, 2, 3, would make 3/4. So from 9 up to 10.5 is 3/4. So this is where 10.5 is. So 3/4 of the way through 9 to 11. In the 9 to 11 class, this is a class, we call that the 9 to 11 class. So, and how many of them are in the 9 to 11 class? 12. So we only want this part because we start at 10.5, the part in green. And that part is just 1/4. So 1/4 of 12. So 1/4 of 12 is 3. So the answer is an estimate because we do not know the number of students who took longer than 10.5 seconds. So we are using interpolation, and the answer we got is an estimate. So we will start with the 3 from that part there, plus 5 plus 4. It gives you 12. Because interpolation, we got 3 plus 5 plus 4 gives you 12. So the probability of finished in over 10.5 minutes is 12 over 40. And when you simplify that, it gives you 3 over 10.